Components of rainwater harvesting system: the catchment, drain pipes, gutter, downpipe, first flush pipe, filter unit, storage tank and collection sump and pump unit. Catchment surfaces include roof, rainwater harvesting platform, the watershed or a hill slope. The roof of the house is used as a catchment for collecting the rainwater. The style, the construction and material of the roof determine its suitability as a catchment. The rooftops used as catchment should contain non-toxic material and the surface should be smooth, hard and dense. Roofs made of corrugated iron sheet, asbestos sheet, tiles or concrete can be utilized as such for harvesting rainwater. Painting of the roof should be avoided. Thatched roofs, on the other hand, are not suitable for the purposes as pieces of roof material may be carried by water and may also impart some color to water. However, these surfaces may be used for covering the same with plastic sheets and fixing a thin bamboo strip frame over it for keeping the sheet in the position. The roof should have one slope for considerable savings on the account of cost of gutter and ridge. The slope should be directed towards the entrance of the house so that the storage tank can be placed at the front of the house. Rainwater harvesting platforms are high level earth deposits or concrete platforms forms sloping towards one side of the collection channels or trenches. Drain pipes are drain pipes of the suitable size made of PVC stoneware or provided in the RCC buildings to drain of the rooftop water to the storm drains. They are provided as per the building code requirements. Gutters are channels fixed to the edges of the roof all around to collect and transport the rainwater from the roof to the storage tank. Gutters can be prepared in the rectangular shapes and the semicircular. Gutters are channels made of either plain galvanized iron sheets or the cut PVC pipes or split bamboo. These channels are fixed to the roof ends to divert the rainwater into the storage tank. Gutters, PVC pipes, storage tanks. Semicircular rectangular shaped channels can be made using the GI sheet. Cut PVC pipes and bamboos are the semicircular in shape and can be easily made. These channels are made at the site of construction and fixed to the roof by using mild steel supports. Use of locally available material reduces the overall cost of the system. Gutters should be installed with the slope towards the down pipes. Number of gutters depends upon the type of roof. In one slope roof system, only one gutter is required. The size of the gutter should be selected, keeping in view flow during the highest rain intensity. Next, we have the down pipes. These carries the rainwater from the gutters to the storage tank. It is joined with the gutters and one end, whereas the other end is connected to the filter unit of the storage tank. PVC or GI pipes of 50 mm to 75 mm, which is a 2 inches to 3 inches diameter, are commonly used for downpipe. In the case of RCC buildings, rain pipes themselves serves as downpipes. Downpipe should be provided with a 20 mm mesh wire screen at inlet to prevent dry leaves or debris from entering it. Size of the pipe depends on the amount of the collected water. The position of the tank should be selected in such a way that the length of the down and the inflow pipes are minimum to avoid leakages in bends and joints. The orientation and arrangement of the downpipe depends on the relative locations of the tank and roof. The shape of the roof and type of the roof also determine the arrangement of the downpipes. First flush pipes diverters. A first flush system is built in the rooftop rainwater harvesting system to dispose of debris and dirt and dust in the first flush water so that it does not enter the tank. There are two such simple systems. One is based on a simple manually operated arrangement whereby the downpipe is moved away from the tank inlet and replaced again once the first flush water has been disposed. In another semi-automatic system, a separate vertical pipe is fixed to the downpipe with a valve provided below the T-junction. By operating the bypass system, the water bringing dust and other undesirable matters from the catchment area is made to flow out of the system and its entry in the tank is prevented. After the first rain is washed out through the first flush pipe, the valve is closed to allow the water to enter the downpipe and reach the storage tank. Next, we have the filtration. Filtration of removal of the suspended and the colloidal impurities is the most important process for water purification. Water is allowed to pass through a filter media, example sand or anthracite made from the anthracite, which is a stone coal. The sand being used for filtered in rooftop rainwater harvesting system should be free from clay, loam, vegetation, organic impurities. It should also be uniform in nature and grain size. Depending on the type of filtration, the chemical characteristics of the water may be altered and the bacterial content considerably reduced. The Antrafit has many advantages such as low cost, high rate of infiltration, and better efficiency. However, sand being readily available is commonly used for filtration. The filter can be divided into three parts, which is a container. Container can be made with the GI sheet thicker than the 18 gauge or with ferro cement. The container is generally circular in shape and rests over an opening provided in the roof of the reservoir. The 4 centimeter diameter circular perforation is used at the bottom for the filter. Filter material consists of the following layers. First layer 40 millimeter thick layer of natural gravel. Gravel size should not be less than 12 millimeter or more than 14 millimeter. Second layer 30 millimeter thick layer of natural fibers of coconut, palm, betel nut, preferably length of fiber 6 to 8 centimeter. Third layer is 80 millimeter thick layer of natural river bed and retained over 1 millimeter size sieve but passes to 3 millimeter size. Fourth layer again 30 millimeter thick layer of natural fibers as in second layer. Filter and top layer, a layer of 80 millimeter size round boulders is used at the top. Filter must be kept free from the contamination and in good condition. Next we have the storage tanks. It is used to store the water collected from the rooftops. Common containers used for small scale water storage are plastic containers, buckets, jerry cans, clay of ceramic jars, cement jars, old oil drums, etc. are some of the commonly used water storage structures. For storing larger quantities of water, the system usually requires a bigger tank with sufficient strength and durability. Different types of storage tanks feasible for storing rooftop rainwater are given below. Storage tanks are the RCC, masonry, ferro cement, PVC. There are a number of options for the construction of these tanks with respect to the shape, the size, and the material of the construction. For domestic water needs, taking the economy and the durability of tanks into consideration, ferro cement tanks of the cylindrical shape in capacities ranging between 4,000 to 15,000 liters are most suitable. Brick, stone, or cement brick may be used for capacities ranging between 15,000 to 50,000 liters. Cement concrete and reinforced cement concrete are used for tank capacities exceeding 50,000 liters. Storage tanks are usually constructed above ground level to facilitate easy detection of leaks, easy maintenance and cleaning, and easy withdrawal of stored water, and are provided with covers on the top to prevent contamination of water from external sources. A tap or outlet drain pipe and overflow pipe are provided for draining, drawing water, cleaning the tank, and the disposal of excess water, respectively. Size of storage tanks for rural areas. Size of the storage tank should be carefully selected considering various factors such as number of persons in the household, water use and duration of water scarcity, rainfall type and size of house roof, and the status of existing water sources in the area. In general, the period of water scarcity for domestic purposes ranges between 90 and 200 days depending upon the quantity and distribution of rainfall and water sources existing in the area. The water use of the household needs to be estimated based on the local culture and habits of the people influencing the water use. Minimum quantity of per capita water needed for survival should be around 50 liters per day. The size of water storage tank may be determined using the following relation. The size of storage tank based on the water requirement liter is equal to number of persons in the household in the into period of water scarcity into per capita water requirement liter per day. The capacity of storage tank, which reflects the total household water requirement during the period of water scarcity, should be compared with the amount of water available from house rooftop during rain. If the amount of water available from rooftop rainwater harvesting is less than the required capacity of storage tank, then the household will have to use the water available from roof only for a Part of the water scarcity periods. Water available from roof is obtained from the following relation. Water available in liter is annual rainfall into roof area into runoff coefficient. Runoff coefficient depends on the type of roof surface and indicates the fraction of the rainwater that can be collected from a particular roof. Runoff coefficients for common types of roofs are the GI sheet is 0.90 and the asbestos is 0.80, tiled is 0.75 and concrete is 0.70. Size of storage tank for urban areas. In major cities and towns where regular water supply already exists throughout the year, the size of the storage tank for harvesting rooftop rainwater can be decided as per the quantum of rainfall occurring in a single event. It is assumed that serious water scarcity period is not considered and the collection of rooftop rainwater is voluntary mandatory as an effort towards saving our natural resources. Moreover, it is difficult to create enough storage space due to various constraints. In such a situation, it is ideal to create the storage space to collect the rainfall for an event and utilize the same before the next spell. Purification of water for drinking. Water collected from a rooftop is generally pure and potable. However, while passing through the gutters and downpipes, it comes into contact with dust, debris, leaves, and bird droppings. Moreover, the water collected in the tank is stored for about 100 to 150 days before using as a drinking water. During this period, water is in the contact with tank wall and pipe fittings. Growth of the algae and the mosquitoes breeding can also take place. The chemical and bacteriological contamination of roof water can be prevented by proper and regular maintenance of the system. The water can be disinfected by using bleaching powder. The dosage recommended is 10 milligram bleaching powder containing 25% of free chlorine per liter of water. Ble- After adding bleaching powder, the water should be stirred and kept without use for about 30 minutes. Chlorine tablets are also available and can be used. One tablet of 0.5 gram is enough to 20 liters of the water. Rainwater harvesting is a technique of collection and storage of rainwater that runoffs as a natural or a man-made catchment such as watersheds, rooftops, compounds, rocky surfaces or hill slopes. Rainwater harvesting is of utmost importance to meet ever-increasing water needs of different sectors and replenish depleted water resources. The harvested water is stored in the village ponds, tanks, and small dams, percolation tanks based on the water availability requirement and utility of water. Rainwater harvesting systems include rooftop rainwater harvesting and surface runoff water for crop production, public health purposes, and recharge of the groundwater aquifers. The problem of the water scarcity could be overcome by proactive role played by community organization for development and management of efficient water harvesting structures. Rain Rainwater harvesting practices vary widely in size, type of construction, material used, and methods of collection and storage. Domestic and community rainwater harvesting systems are generally used. In domestic system, rainwater is harvested from roofs, courtyards, and the small catchment platforms and is stored in the storage tanks from an individual household. While in community system, rainwater is harvested from watershed areas and the roofs of group housing societies and used for domestic as well as groundwater recharge. Catchment watershed roof drain and downpipes, gutters, flush pipe, filter unit, storage tank, and collection some well are the main components of rooftop rainwater harvesting system. The size of the storage system depends on the water requirement of a household, group housing society, and the water scarcity period. Aquifer is the water-bearing subsurface strata which stores as well as the release water. Catchment areas contributing to the runoff, diversion, change of direction, filtration, intercepting impurities like bird dropping, dust, leaves, texture to a filter to ensure clean water. Flush, dispose of groundwater, recharge, replenishment or recharge of depleted groundwater storage by rainfall or irrigation. We have the percolation tanks, water storage tanks with the porous water material so that the water percolates into the ground very rapidly. Water harvesting potential, maximum amount water which can be harvested from an given area.